I am Edward Shore. I have been a calculator collector and connoisseur since 1990. I was in middle school, about the sixth grade when I started collecting calculators. I have a master's degree in mathematics and also a accounting degree, both from Cal Poly Pomona. And it is good to speak with you all today. And hopefully, this time next year, we'll actually be meeting in person because I love going to these conferences. Anyway, I do have a math blog. It's edspie31415.blogspot.com. But what I'm here to do today is to talk about computer algebra systems in calculators. It's fairly so. What is the computer algebra systems? We're going to talk about calculators that have CAS, some essential CAS functions, and then how has it affected the educational market. And then I also want to share some of my thoughts, what I think is going to be the future of any calculators with computer algebra systems. So, what is CAS? If you're not familiar, CAS stands for Computer Algebra Systems, which is basically symbolic manipulation of algebraic objects and interpreting and parsing mathematical expressions. Do you remember in your algebra class where you had to complete the square, or you had to simplify expressions such as x times the quantity of 2ax minus 3, and you need to show each step? That's basically what CAS does. It does the work that you would probably write on paper and pencil, or paper and pen. And often the results can be displayed as it would be written on paper or the chalkboard. It's usually called pretty print, math print, um, natural print, that it's sometimes called. But it's displayed in that format instead of this one line of expression with full of parentheses. Symbolic answers are allowed without the calculator requiring you to use numeric values for each variable. So, for example, if I have the expression x squared plus a times x minus b, you can manipulate that expression without having to enter a value for either x, a, or b. CAS-enabled calculators are also the first to simplify most rational expressions exactly. So if I have something like 7 divided by the quantity of 6 plus the square root of 7, that can be simplified to -7 times the square root of 7 plus 42, all that divided by 29. And what it does in the simplification, of course, it multiplies the first fraction of 6 minus the square root of 7 over 6 minus the square root of 7. One of the first, if not the first, calculators with CAS functions is the Casio FX5500. This is different from the better known FX5500L. The 5500, it has a landscape design and has a QWERTY keyboard, and it's configured more as a pocket programmer. If you want to see a picture, you can go to Ladudu's Casio page, a very excellent source of all things Casio. What the 5500 offers is simplification of polynomials, expanding and factoring polynomials, and then it offers a range of CAS functions, but it only works on expressions with arithmetic operators, powers, and roots. Nothing on trig identities, logarithmic or exponential identities, no advanced calculus as of yet. So this is like basically the ground floor of CAS operated calculators. So What calculators do have CAS? I'm pretty sure you all are familiar. With the Hewlett Packard, it started pretty much with the 28 family, the 28S, 28C with its magnificent RPL engine. Then it went to the 48 series, 49, and 50G, and of course the HP Prime. On the Texas Instruments side, you have the TI 8992 series. And if anything, if you have the TI Inspire, it would have to be the TI Inspire CAS. Those have computer algebra systems operators. If you get the TI Inspire plain, it will not have CAS. On Casio, as I mentioned before, the FX 5500. Then you got the Algebra FX series. There was a 1.0, which I have never seen, and a 2.0. I used to have a 2.0. But Casio's most advanced calculator is called the ClassPad series. And it started with the 300, the 330, 400. Now they got the 500, and it's a really huge calculator with the stylus. The 500 and 400 both have a color screen. The screen can rotate. It's got a lot of soft keyboards on the ClassPad. Not only calculators have CAS operated calculators, you can get that on your phone. On Android, Maxima has not only CAS functions, but also a programming module you can use. One of my most favorite places and apps is the Wolfram Alpha. You need to be connected to the internet to be able to use it. You can use Wolfram Alpha on free if you're on a computer, but if you're using it on your iPod, iOS, iPhone, on your smartphone, it's a relatively small cost, about $3, and it gives you the ability. And Wolfram Alpha just gives you so much ability to do a wide range of mathematical problems, including computer algebra systems. Also, I haven't checked this out, but there's also called Math Studios for the iOS engine, and it's supposed to include computer algebra systems as well. So, what are the essential CAS functions? Some of them start with a simplification. So you can simplify numbers in terms of square root, in terms of pi, and fractions. This first section here on top, you can also see this simplification on GeoAlgebra, some of the advanced solar powered scientific calculators, non-graphing calculators such as the TI-36 Pro or the TI-30 Pro Print or the Casio FX 115991. They will also have this type of simplification. In fact, now that I think about it, I think almost all modern graphing calculators have simplification now. The next essential CAS function is factorization. Now, you can have factorization of integers, but it also factorizes polynomials. So usually either you're going to have a factor command that does both integers and polynomials, or have two separate commands like the HP Prime here. The ifactor is the factorization of integers. So if I take an I factor of 1250, I end up with the 2 times 5 to the square root, 5 to the 4 power, excuse me. And then factor by itself factorizes polynomials, and it probably also factorizes any other expressions the system can use. So if I was to factor x cubed minus 7x squared plus 15x minus 9, I get x minus 3 squared times x minus 1. You also have the ability to expand polynomials in any other expressions. For example, if I expand the combination function of x3, I get the function x factorial over 6 times 1 over x minus 3 factorial. And there's also synthetic division. One of my favorite commands is the partial fraction function. And what that does, it splits a rational function into a sum of terms and then plus a remainder. And you can use partial fractions to invoke synthetic division. You can also use it as an aid to integrate expressions that you have to use partial fractions. Now, some advanced calculators and graphing calculators do have sums that you can take an expression and make a sum with numeric arguments. But with CAS-enabled calculators, you can take that to another level, and you can use symbolic arguments. You can also use arguments concerning infinity. So if, for example, I have the sum of n squared, where n is equal to 1 to x, and then I can get a closed formula for it. 1/6 times the 2 to x times x cubed plus 3x squared plus x. Another calculus function that you'll find is limits, and all kinds of limits. It's just normal limits, limits to the left, limits to the right, positive, negative limits, limits to infinity. And then you have derivatives, both numeric and symbolic. And then you also have integrals, both numeric and symbolic, indefinite and definite integrals. And depending on the strength or the expansion of the computer algebra systems your calculator is running on, you can get a nice set of indefinite integrals and simplifications. So if you have a good CAS-enabled calculator software, there really is no need to carry around math tables anymore that has a table of integrals, or don't have to worry about the internet. Have to worry about, oh, is my phone connected to the internet? Because you can go to your calculator and get that integral that you need. You also have real uncomplex solutions. Now, this is primarily determined by two functions, actually 4 functions. If you want to find the roots of a function, there's zeros for real roots and C zeros for complex roots. Then it's expanded to the more generic solver. So you have solve for real roots and C solve if you want to involve complex roots. So if I have solve of sine of x equals pi over 2, well, you're not going to have any real solutions. So it's going to return blank. But if I say C solve of sine of x equals to pi over 2, then I get two principal solutions: pi over arcsine of pi over 2 and arcsine of pi over 2. And as you know, arcsine of pi over 2 gives you the complex number pi over 2 minus about 1.02i. There are challenges to using computer algebra systems. You are dependent on how complete and complex the CAS system is. There are also bugs. There could also be bugs in the computer algebra system. If you are a member, or if you search the Museum of HP calculators, from time to time on the HP Prime section, people will bring up a couple of bugs and of CAS related functions. There's also a learning curve. Can the user create programs or easily understand all the essential CAS functions and some of its explanations? Also, how easy it is to find all the CAS functions that they want to get to. Then there's the issue is, if you have a CAS calculator, how would that calculator be allowed in the classroom? And it's not only just high school, or I can't imagine a CAS calculator being allowed in middle school classroom. Who knows? Who knows nowadays? But also university. Does the university class allow CAS calculators, CAS enabled calculators? And then on the flip side, if CAS-enabled calculators are accepted by the school and the university, do the teachers use it to teach mathematics, and to what extent can mathematics can be taught? And if you choose to program with CAS, your mileage is definitely going to vary. If you have, it could be limited and complex at best, like the Casio FX Algebra series. I don't know if you even can program any CAS functions in that series or not. It's been a long time since I've operated that calculator. And then you got a high learning curve like the HP Prime. I don't. The HP Prime is operating on the programming language based on the HP 38 and the 39G series, which is primarily a numeric series, and then you're adding computer algebra systems to it. That's going to take, how is that, how are all those commands going to work together? Also, you have a separate CAS page for the HP Prime, and you also have to designate which program um, has CAS operating. The best integration that I've seen on the calculator, that would be the TI 8992 series with the TI Basic, and then any of the RTLs with the HP 28, 48, 49G series. I just like the integration between and the easiness of being able to throw in a CAS enabled command and not have to worry about switching to different modes, not have to worry about syntax. It handles everything just nice. What programs are allowed to do is to be automated repetitive tasks with both numeric and symbolic inputs. An example here with the HP Prime, CAS test 03, I have two arguments, F and A. F is going to be a function of X, and A is going to be your substitute. And you can use CAS test 03 in the CAS mode for both numeric and symbolic functions. So, for example, if I could substitute X to be equals to A minus B squared, then there's an educational and CAS issue. So, how do you balance between CAS and learning how to solve problems manually? How can it be used to effectively teach mathematics? And the use of CAS in those mathematics presentations. Since computer algebra system functions are used to do a lot of legwork for the students, how can we use those functions to push the student to go further in their studies in mathematics or try for understanding? So you could explore patterns. So students can look at if you take x squared and you multiply by x cubed, and then x squared by x to the fourth power, and so on, you can tell what happens to the final product as you keep going, as you keep increasing the exponent of the second term. And if you do, you can use repetitive what if patterns to determine, like, okay, we can develop a general rule. One of my favorite part of CAS enabled calculators is to do manual step-by-step solving. So what happens is in CAS mode, the variable ANS, last answer, will store the expression, both sides. So for example, I have 8x squared minus 66 is equal to 0. If I do ANS plus 66, it adds 66 to both sides, resulting in 8x squared is equal to 66. And then you can just keep on going, divided by 8, and then you can take the square root for the answer, which is plus or minus 30, square root of 33 over 2. However, since calculators don't have a plus or minus, it would display the answer as the absolute value of x is equal to square root of 33 over 2. This is definitely probably one of my favorite features of computer algebra systems. Another one of my favorites is to verify trigonometric and logarithmic identities. And it depends really on the system that you're using. You may have to use specialized commands like texpand, lncollect, and expand. So it's just really you have to be willing to learn what the commands are. Also, if you were to present calculators that use computer algebra systems in a classroom setting or a presentation setting, you probably really want everybody to use the same calculator or to use the same computer algebra systems. That way, everyone's going to be on the same page. There may be some drawbacks. Students may develop an over reliance on computer algebra systems. So if you're if you have your classroom and if you have your test mode and you turn it off, you turn the CAS abilities. Well, if the students kept over relying on the on computer algebra systems and not learning the middle steps, they're in trouble because they're going to have to show their work. They're going to have to get they haven't really learned the concept. There's also a learning curve of CAS commands. We got it for the most effective way for not only the classroom but for real world working. The commands are going to have to be easy to use, have to have a wide breadth of problems it can work with, and a good understanding of its limitations. Depending on which settings you use, maximum simplification, no simplification, some simplification, some of the middle steps can be stepped. You can also get unrespected results. Um, a lot of the trig of X, a lot of work with trigonometric functions usually default to have functions of sine of x when you were expecting an expression of cosine of x. So there may have to from time to time to be reconciliation with if there is the result you are getting correct. Ultimately, it will be up to the students to develop self-discipline. I don't know if the requirement is to show your work is going to disappear, especially, but that might be helped by the environment we are in now. CAS is great, but it is evolving. And I think when you use computer algebra systems and their commands, I think you still need to have at least some kind of working knowledge of mathematics. Otherwise, you can do things all day and not understand what could go wrong. And if you run into a bug, you you might accept an answer blindly that may not be the best solution. I think every student or every advanced calculator will end up having CAS capabilities at some point. I don't know to what extent it will have all the scientific calculators. I figured that maybe the next line of advanced scientific calculators will have some type of CAS functions, maybe like the old Casio FX5500, where you have simplification, expanding a polynomials, factoring a polynomials, maybe do some synthetic division. I do expect the integration of CAS into all the calculators to be slow. I do also notice that CAS capabilities might be present into calculators that may not even offer CAS commands, but the capabilities inside the calculator will be able to solve functions more efficiently, calculate integrals more efficiently. You Some calculator apps have a dedicated equation library, like the 48G, 49, or the 50 series. You may need to start seeing like solving for a certain variable instead of just substituting values. So I also expect more as apps on the smartphone to have more CAS capabilities. Probably the apps that will probably be developed is going to be more specialized rather than generic, because you got developers who want to solve a certain type of problem. And that is my thoughts on computer algebra calculus with computer algebra systems. It's pretty much been a slow build until the TI-89 and the HP-28 came up, and then it's been it's an evolving process, and it's really I'm excited to see where it goes. Thank you.
Thank you, Eddie. That was great.